Good morning, my dear students of Standard 9. Welcome back to the chemistry class. Dear students, we had completed chapter 6 from your chemistry book. Today, in this class, we will discuss about the exercise from this chapter. So, at first, multiple choice question. 1 number question, what is the volume of 2 grams of hydrogen at standard condition? Dear students, we know at standard condition means at STP. At STP, the molar volume of gaseous substance is 22.4 liter, and molar volume, that is the volume of 1 mole substance. 2 gram hydrogen, the molecular mass of it, because molecular mass of hydrogen is 2. So the molar volume of hydrogen gas is 22.4 liter. That means the volume of 2 gram of hydrogen is 22.4 liter at STP. So it will be C number option, 22.4 liter. 2 number MCQ, which of the following is the formula of calcium phosphate? We know in calcium phosphate there are calcium and phosphate radical. The valency of calcium is 2 and the valency of phosphate radical is 3. So the formula will be Ca3PO4 2. So it will be D number option, Ca3PO4 2. Now answer questions 3 and 4 in the light of the following stem. The stem is 5 gram hydrogen gas is passed on to 75 gram chlorine gas. So both are reactants here. Here 5 gram hydrogen and 75 gram chlorine are mixed. And hydrogen and chlorine, they both will react to produce hydrogen chloride. And look, here the amount of both reactants are given. One reactant hydrogen, there are 5 gram hydrogen, and another one is chlorine, there are 75 gram chlorine. Now 3 number question, how many chlorine atoms are used in the reaction of the stem? Look, there are 75 gram chlorine, but we have to find out this 75 gram chlorine is fully used or it will be remained in the reaction chamber. If 75 gram chlorine is fully used in this reaction, then chlorine will be limiting reactant and we will find out the number of atoms present in 75 gram chlorine gas. But if we see that 5 gram hydrogen is fully used in this reaction and some chlorine gas is remained in the reaction, then 75 gram chlorine will not be fully used in this reaction. Some chlorine will be remained. That time we will find out how many chlorine gas is used to react with 5 gram hydrogen, and we will find out the number of atoms present in that amount of chlorine gas. So here, look the math. Here, 2 gram hydrogen and 71 gram chlorine will react. So we can write 71 gram chlorine reacts with 2 gram hydrogen, and in our reaction chamber there are 75 gram chlorine. So 75 gram chlorine reacts with 2.11 gram hydrogen. But dear students, look, in your reaction chamber there are 5 gram hydrogen, but to react with 75 gram chlorine we need only 2.11 gram hydrogen. So what is the limiting reactant? It will be chlorine, because 75 gram chlorine will be finished from the reaction chamber. That means 75 gram chlorine will be fully used in this reaction, and we will find out the number of atoms present in 75 gram chlorine. We know the molecular mass of chlorine is 71. So in 71 gram chlorine there are 6.02 into 10 to the power 23 molecules. 75 gram chlorine means 6.36 into 10 to the power 23 molecules. But you have to find out the number of atoms. Chlorine Cl2, it is diatomic molecule. In one molecule chlorine there are 2 atoms. So in this amount of molecules, there are 2 into this. That means it will come 1.27 into 10 to the power 24 atoms. It will be our A number option. So the answer is A, 1.27 into 10 to the power 24 atoms. Now 4 number question, which of the following is collected as remains in the reaction? Dear students, from 3 number MCQ, already we knew that chlorine will be fully used in this reaction. So which one will be remained? Hydrogen. And we have to find out how many hydrogen gas is collected as remains in the reaction. Look, already we know this remaining amount of hydrogen, and hydrogen, it was used, we saw in our previous option, previous math, hydrogen was used 2.11 gram, but in our reaction chamber there are 5 gram hydrogen. So how many hydrogen will be remained? 2.89 gram. 5 minus 2.11, it will come 2.89 gram. Look, here all the options are in mole. So we have to find out 2.89 gram means how many mole. We know 2 gram hydrogen means 1 mole hydrogen. So 2.89 gram hydrogen means 1.44 mole hydrogen. So which is the correct answer? A number option, 1.44 mole hydrogen. Now 5 number MCQ, what is the volume of 17 grams of ammonia gas at standard condition? Again, we know volume of a gaseous compound, volume of 1 mole of gaseous compound is 22.4 liter at standard condition. 17 gram ammonia means the molecular mass amount ammonia. That means it is 1 mole ammonia. So the volume will be 22.4 liter because 1 mole ammonia is 17 gram ammonia and the volume of it is 22.4 liter at STP. So our answer will be B number option, 22.4 liter. Now the last MCQ, how many molecules are there in 10 gram of calcium carbonate? How many molecules are there? We know in 1 mole compound there are 6.02 into 10 to the power 23 molecules. The molecular mass of calcium carbonate is 100. So 1 mole calcium carbonate means 100 gram calcium carbonate equals 6.02 into 10 to the power 23 molecules calcium carbonate. That means 10 gram calcium carbonate means this divided by 10, it will come 6.02 into 10 to the power 22 molecules calcium carbonate. It is our C number option. So the answer will be 6.02 into 10 to the power 22. Now creative question. 1 number question. Look, this is the stem. There is one bottle, there is another bottle. Everywhere there are 100 ml substance. This is 100 ml HCl and this is 100 ml sodium hydroxide. In this 100 ml HCl, there are 4 gram HCl. 4 gram HCl is dissolved into water to make it 100 ml. And here there are also 4 gram sodium hydroxide. 4 gram sodium hydroxide is dissolved into water to make the solution 100 ml. Okay. Now the question is, what is a mole? You know, the gram molecular mass amount of a compound is called its mole. Not only this, if in a substance there are 6.02 into 10 to the power 23 molecules or atoms present, and or if the volume of a substance is 22.4 liter at STP for gaseous substance, that is called mole. Now B number question, what do you understand by empirical formula and molecular formula? We learned this, empirical formula and molecular formula. Empirical formula that expresses only the ratio of the atoms present in a molecule, and molecular formula represents the exact number of atoms present in that molecule. Now see number, determine the composition of the salt that can be formed by combining the solutions shown in the stem. Composition means percent composition. Here you have to find out the percent composition of the salt. Look, this is an acid and this is a base. And we know if these two are mixed, then neutralization reaction will be occurred and salt and water will be produced here. So we have to find out the percent composition of the produced salt by their reaction. Look, HCl acid, sodium hydroxide salt. So they will react to produce sodium chloride salt and water. We have to find out only the percent composition of this salt, because here there is given determination the composition of the salt that can be formed by combining the solutions shown in the stem. So in sodium chloride there are two atoms, sodium and chlorine. We will find out the percent composition of both atoms. You know the way. The molecular mass of sodium chloride is 58.5. So the percent composition of sodium in sodium chloride is, there is only one atom sodium and the atomic mass of sodium is 23. So 23 divided by 58.5 into 100. It comes 39.62%. And the percent composition of chlorine in sodium chloride is, chlorine, it is also one atom, and the molecular atomic mass of chlorine is 35.5. So 35.5 will be divided by the molecular mass of the compound 58.5 into 100. It comes 60.68%. This is our C number question. Now look, will the molarity of the shown solutions be the same? Give a mathematical explanation. Here volume and amount are given, mass and volume are given. We have to find out the concentration. We have to find out the molarity of both component, and we have to compare the molarity are same or not. So at first we will find out the molarity, the concentration of these two. We know molarity, that is mole per volume in liter. Okay, molarity equal mole of substance divided by volume in liter. There are 4 gram HCl and 4 gram sodium hydroxide. If the mass of a component is divided by its molecular mass, then we will get the mole number. So how many HCl, how many mole of HCl are there? 4 gram divided by molecular mass 36.5. So there are 0.11 mole HCl present in this solution. In the same way, if we divide this amount by its molecular mass, then we will get the mole number of sodium hydroxide present in this solution. Here sodium hydroxide, the mole number of sodium hydroxide is 4 divided by 40. It comes 0.1 mole. Look, HCl we got 0.11 mole and sodium hydroxide we got 0.1 mole. Now you can easily determine the molarity of them because we know the volume. Both are 100 ml. So the molarity of HCl is mole 0.11 mole and volume we have to find in liter. 100 ml means 0.1 liter. So the molarity of HCl is 0.11 divided by 0.1. It comes 1.1 molar. But for sodium hydroxide, it is 0.1 mole and volume is also 0.1 liter. So it comes 0.1 divided by 0.1, 1 molar. So the concentration of which one is more? HCl, it is 1.1 molar and sodium hydroxide, it is 1 molar. So the concentration of HCl is more than the concentration of sodium hydroxide. Now second question, 2 number question. Look, the stem. 4.4 gram carbon dioxide and 5 gram calcium oxide are mixed to prepare 10 gram calcium carbonate. Look, 4.4 gram carbon dioxide and 5 gram calcium oxide. Both are mixed, and you know that carbon dioxide and calcium oxide, they react to produce calcium carbonate. So after mixing, 10 gram calcium carbonate is produced. The expected yield is not made after the reaction is over. When the reaction is over, the expected yield is not made. Look, to prepare 10 gram calcium carbonate, this amount are mixed, but after the reaction, it is seen that the expected amount, that means 10 gram calcium carbonate, is not produced. We know when the expected amount of product is not produced, if there is any impurity. If there is any impurity present in calcium oxide or carbon dioxide, or if we take lesser amount of carbon dioxide or calcium oxide, then we will not get the expected amount of product. We have to find out that. A number question, what is the chemical equation? All you know what is chemical equation. B number question, explain the molar volume of carbon dioxide. Molar volume of carbon dioxide. We know the volume of 1 mole component is called its molar volume, and 1 mole of a component, that is the molecular mass amount of that component. Carbon dioxide, the molecular mass of carbon dioxide is 44. So the volume of 44 gram carbon dioxide is 22.4 liter, because the molar volume of any component at STP is 22.4 liter. So the molar volume of carbon dioxide is 22.4 liter. Now see number question, determine how many moles of carbon dioxide were used in the reaction. Look, here 4.4 gram carbon dioxide and 5 gram calcium oxide are mixed. Here you have to find out how many moles of carbon dioxide were used. 4.4 gram carbon dioxide is taken, but we have to find out the full amount of carbon dioxide is used or not. If the carbon dioxide is limiting reactant, then we can tell that the full amount 4.4 gram carbon dioxide is used. But if carbon dioxide is remained in the reaction chamber, then the full amount will not be used. It is same as the MCQ question. So at first we will find out which one is the limiting reactant, because here the amount of both the reactants are given. This is the reaction. Carbon dioxide and calcium oxide are mixed and calcium carbonate is produced from there. Look, 44 gram carbon dioxide reacts with 56 gram calcium oxide, and in our reaction chamber there are 4.4 gram carbon dioxide. So 4.4 gram carbon dioxide reacts with 5.6 gram calcium oxide, but in the reaction chamber there is only 5 gram calcium oxide. So calcium oxide is the limiting reactant. Before reaction, calcium oxide will be finished. So 4.4 gram carbon dioxide will not be fully used in this reaction. Now we will find out how many carbon dioxide is used here. Here look, we can write here again 56 gram calcium oxide reacts with 44 gram carbon dioxide. So 5 gram calcium oxide reacts with 3.93 gram carbon dioxide. Look, in your reaction chamber there are 4.4 gram carbon dioxide, but 4.4 gram carbon dioxide is not fully used in this reaction, because before finishing carbon dioxide, calcium oxide is finished. So only 3.93 gram carbon dioxide can react with 5 gram calcium oxide. So 3.93 gram carbon dioxide is used in this reaction, and we have to find out the mole number of 3.93 gram carbon dioxide, not 4.4 gram carbon dioxide. So 3.93 gram carbon dioxide means, we know 44 gram carbon dioxide means 1 mole. So 3.93 gram carbon dioxide means 0.089 mole. This is the used amount of carbon dioxide. It is our C number answer, 0.089 mole, because you have to find out how many moles of carbon dioxide were used in the reaction. Now look, D number question, give a logical explanation of the lesser yield than expected in the reaction of the stem. You have to do it mathematically. You have to give a logical explanation. Why the expected amount, that means 10 gram calcium carbonate. Why 10 gram calcium carbonate was not produced in this reaction? We have to find out this. Already we got that here calcium oxide is limiting reactant and 4.4 gram carbon dioxide is not totally used. If 4.4 gram carbon dioxide is totally used and if some more amount of calcium oxide is present in this reaction, then some more product can be obtained. So there are two reasons. One is the lesser amount of calcium oxide and the remaining amount of carbon dioxide. If the total amount of carbon dioxide can be used, or if some more amount of calcium oxide is present in this reaction to react with the remaining carbon dioxide, then we can get some more amount of product. We will find out it mathematically. So from C, already we have seen that the needed amount of calcium oxide is 5.6 gram, but we have only 5 gram. So there 0.6 gram calcium oxide is shorter. If 0.6 gram calcium oxide more present here, then the full amount of carbon dioxide can be used. Then we can get some more amount of product. Again, from C, we found that 3.93 gram carbon dioxide was used to produce the product. That means 0.47 gram carbon dioxide is remained in the reaction chamber. 0.47 gram carbon dioxide is remained in the reaction chamber. Now look, from 56 gram calcium oxide, product is 100 gram, because from the reaction we can see this. 56 gram calcium oxide reacts with 44 gram carbon dioxide to produce 100 gram calcium carbonate. But there are 5 gram calcium oxide. So 5 gram calcium oxide, we can get how many amount of product? 8.93 gram calcium carbonate, where it was said that the expected amount of product was 10 gram, but we got how many? Only 8.93 gram. So why we get this less amount of product? I told there are two reasons. One is there are 0.6 gram calcium oxide less in the reaction chamber and 0.47 gram carbon dioxide is remained in the reaction chamber, and so we don't get the expected amount of product. That means 10 gram. We get only 8.93 gram product from this reaction. So this question mathematically you have to give the logic. So dear students, these two, and we have done mini math in our class time. Practice all these today up to this. So thank you everyone. See you in next class.